So let us continue. We'll stay with the same zone of rock. We had compared the halite, the quartz, and this sample because they all certainly are non-metallic and they had a similar kind of tonality to them. But I think we'll find immediately that if we take a piece of quartz here and whatever this might be, this bigger one, let's take the smaller one, we can see that there's something clearly different about them. This is broken unpredictably, it's fractured, and this has broken predictably. This cleaves. This has a atomic structure that allows it, when it's knocked, to break only along certain planes of weakness that are determined by the way in which the atoms are arranged. It's internal arrangement of atoms. So this sample always breaks in the same manner. It always breaks with two angles, one at about 60 degrees. Let's double check if if it gives me, they call it a rhombohedral cleavage, which if you look at your reference table, you might already identify this. But let's check how hard it is. So I have the glass right here. Let's see, right in the middle. You hear anything? I don't hear anything. Do I feel anything? I don't feel anything. This is softer than glass. So why don't we go here to the streak plate. I'm gonna rub my finger here, nothing comes off. But let's put this on the corner and rub it. Oh, if you'll note, there is a fine powder there, I think you can see. And if I take my finger, you can see it on my finger. So this is softer than glass, has a cleavage that is in two directions at a particular angle. Doesn't really have a color. Can't be talc, can't be sulfur, maybe gypsum, but gypsum has cleavage, is soft, it is sort of whitish, so we could see that in the middle. It's not mica, not halite, not mica. Calcite, that is pretty soft, as is a dolomite here. Why don't we check? Oh, look, bubbles with acid. So I'm gonna hold this close up here, so hopefully we can see if anything happens. Can you see? I'm not sure. Can you see? There we go. You might be able to just see that is bubbling. This definitely bubbles when I drip a little bit of acid on it. Let's check the other samples, see if that's true with this one. See if we can see it. It is, to my eye, bubbling. I'm not sure you can see it, but I hope you can. That is carbon dioxide being released. Calcite, main ingredient in limestone and marble, economically tremendously important mineral. Did we do these? I think we did these only in the sense that we know that they are non-metallic, and I think you understand that these have a cleavage plane. You see how this reflects light along this plane here? You see it a bit on this plane. That's cleavage. You don't see that in fracture. You don't see it reflecting light in that same way. It does reflect some, but it doesn't reflect it along a smooth plane where the mineral broke. Likewise, these have a similar color in that they're all kind of pinkish white. So cleavage, pinkish white, non-metallic. So we don't have that many left here. We've gone through talc, sulfur, not gypsum yet, mica, halite, muscovite, biotite, calcite, dolomite. We haven't seen fluorite. Then we have the pyroxene, amphibole, potassium, feldspar. Why don't we go over here and see what we've got? Well, cleaves, definitely two directions, yes. White to pink, I like that. And let's check its hardness. Well, it's 6. So that means it should not leave a streak. Let's test that. Put it here. Yeah, it's got that horrible sound of not leaving a streak. No streak. And, but when we rub it on glass, let's see what happens. We'll go to the other end here. And I hear something. And put it on some black. And let's see. Whoa! I got 3 amazing little sections where I have scratched the glass. And how can I test it? A fingernail? Yes. A fingernail? Yes. A fingernail? You can hear it. This leaves 4 minerals. And I'm going to tell you right now, 2 of them I know for certain. And 2 of them, I'm not sure what they are. The certain is this, which has fracture and green-ish color. Green is not the only color it could be. But I believe that we have here a piece of, well, actually, I'm rubbing it. I think I was right the first time. I rubbed it with a hardness of 4, and, well, voila. So I think I was right. Fluorite has often got this greenish hue. Now, as far as the cleavage and fracture, this has got, to my eye, no cleavage. But clearly would be described as having fracture. But the color and the hardness are going to say to me that we have a piece of fluorite here. Then the other one I said I knew what it was. This one, a very tricky one. This is an amphibole. You can tell from these, you can see the little lines, which are cleavage planes. If you blew these up under a microscope, you would see that the cleavage, the lines form angles, and the angles are predictable. And according to your reference table, amphibole always cleaves, always breaks, amphibole here at an angle of 56 degrees and 124. That precise is the internal arrangement of atoms in this mineral, that it always breaks in that way. But the problem, of course, is that the samples that you're dealing with are usually so small that unless you blow up the sample under some kind of a microscope, you won't really see that. This is a mineral which we find in other rocks. This is Amphibolite, which is a metamorphic rock that has hundreds of pieces of amphibole in it. Now, based on the hardness of reported here on your reference table, amphibole is a hardness of 5.5. It's black, yes, it cleaves. We could check its hardness and see if it leaves a streak at 5.5 or not. No streak, nothing comes up there. Let's see if it can scratch the glass. It's right on the border. It sounds like it. Sounds like we got something, yes. And if I put this on black, this would be the one below, the one on the top left, I guess, or right. Well, anyway, right here. And you can hear I've scratched the glass. I think with that, we have finished all the minerals. We've identified pretty much all of them. We'll go through that in a second. So we're back. Again, here was our mystery. Dolomite, maybe. That's my last guess. I don't know where I got this sample, so that's another mystery. I'll look into it. We'll put it aside. Pyroxene, I'm pretty confident. Fluorite, with its green, though it doesn't exhibit cleavage. Amphibole, I'm certain. Samples are always hard to come by that are easy to identify if you're not familiar with it. Feldspar, always easy to identify, even in its gray and white form, because of its cleavage and hardness. Quartz, typically easy to identify because of its lack of cleavage, its fracture, and its hardness. Calcite, just dip a little acid on it, bubbles, you have nothing else. Graphite, pick up the mineral. You can always write a note and put it in a bottle if you are lost. Hoping somebody on the other side of the ocean will find it. Sulfur is easily identified by its color, fracture, softness. Hematite even leaves a mark on this paper, though not as easily as graphite because it's a little bit too hard. It scratches the paper. Talc, from which we make talcum powder, comes off. Does it on the paper? Not quite. but very soft mineral. Our salt, which we identified with taste, cleavage, clear color. The micas, which look like little pieces of plastic, dark brown. Your biotite, clear. Your muscovite, that's cleavage. That sets it apart. It's also soft. Our pyrite, metallic, has cubic form, but not when it breaks. Yellowy, brassy color, leaves a black to yellowy, yellowy sort of greeny, black to greeny streak. And your galena, soft, dense, and leaves a streak. Not on, well, yeah, a little bit on the paper. It's a little bit too hard for the paper. Those are your minerals.